Director at the Center for Irrigation Technology. We're going to show you a little bit about tensiometers and how to demonstrate how to install them. So this is what it looks like when you get it straight from the factory. There's this plastic thing on here that protects the gauge. Right, so this is the gauge. It's just a regular pressure, or not quite a regular pressure gauge, but it works just the way a pressure gauge does. The other important parts of this, the white bit on the end, this is actually a porous ceramic tip. This is what is the interface between the soil and the water that's inside this. This is the tube, so that's your water reservoir. Then up here at the top, you've got another reservoir, and you'll see this little black thing. That's a stopper, right? And there's a little hole down in there. And so that's where you would take this syringe, which Sean has, and we'll show how that works in just a minute. But before you install one of these things, you're supposed to soak it in water for a couple hours. Easiest just to put it in a bucket overnight. But you need to put water in here, and then you put the whole thing in the water and leave it there for the next morning, because you want to have water inside this porous tip, because that water gets hydraulically connected to the water that's in the soil and the water that's in this tube. So the way this thing works is that once it's installed and you've got water moving in and out of this tube through that porous tip. So as the soil dries out, it pulls the water out of this tube. And as the soil wets up, it goes back into the tube. And you can see how far down or up it's gone by this gauge. This gauge is basically measuring suction, right? It's measured in centibars. So when you install this in the ground and this is full with water, you're going to see the pressure's pretty low. And then overnight, as it starts to equilibrate with the soil, water's going to flow out. It's going to pull down the water, and this plug prevents air from going in, so you're going to form a vacuum inside here. And this pressure gauge will tell you how much vacuum it is. Now, this is a really useful measurement because you are basically measuring the force that's applied to the soil, or the force that the soil applies to the water, right? That's the same force that the trees have to overcome when they're taking water out of the soil, right? So you're measuring basically what the plants feel when they're trying to get water out of the soil. And you can manage irrigation with this thing. UCANR has some publications that tell you what the centibar readings should be when you need to irrigate and what centibar readings look like when you're wet. Now, this gauge goes from 0 to 100. Now, it's measuring suction, right? So 0 means no suction. That's when the soil is wet. And as the soil loses its moisture, this gauge is going to go up and up and up. But every soil type is a little bit different. So what dry looks like is going to depend on the soil type. And there are guides for all the soil types, and UCANR has guides for both soil type and crop type, because some of the crops are a little bit different. Some can handle more stress, some can handle less. So this is a good way to measure soil moisture indirectly, because you're not measuring moisture content, you're measuring tension. But you can relate tension to soil moisture content. Then there's some tables out there that can help you do that. But it measures soil moisture indirectly, and so you can manage your soil moisture using one of these. So Sean and I are going to go through the installation process, but we also have Jacob Moreno here. He's the rep from Aerometer. He's going to be looking over my shoulder, and every time I make a mistake, he's going to tell you, Charles screwed that up. And he might hit me too, so I'm going to stand over here. All right. So let's go through the installation process. First thing you need to do is make a hole for this thing to go into the ground. There's two ways you can do that. We have this thing, which is a giant slap hammer, but you can also use a 1/2-inch piece of pipe, right? Basically, you need a hole going into the soil that's roughly slightly less than the diameter of that tube. Right? You want it to go all the way down so that the tube, the ceramic tip, is touching the bottom of the hole. And you want the probe to not go down so far that the gauge is touching the soil. And we'll show you that as we're putting it in. Now, I'm going to use this because it's a little bit easier. It's also easier because the soil is really wet right now. So I can basically push this thing in by hand. But that little bit of orange tape you see, that's about how far you want it to go down, right? So that's about 12 inches. So we can push that all the way down and push the probe down to the bottom of that. If the soil is very dry, it's going to be harder, right? You can use an auger, but an auger might make a larger hole, and it's really important that this thing be touching the soil when you install it. So one of the things that they recommend you do is create a slurry with the soil. You put some of it around the tip, that's when you push it down, and you also pack slurry around the side so that you get a good vacuum seal. But you can do all that, and you'll still get a good seal with this. With these surface ones, it's a little bit easier. With the deeper ones, it's quite a bit harder, right? You can push it down, and you want to push it down so that you feel the force of this thing pressing against the soil. If you're installing this in a surface irrigated field, you need to leave a little bit more because you don't want the gauge to be underwater when you're irrigating. But for drip systems and micro sprinkler systems, it's quite a bit easier. So the general recommendation is to have the probe in the soil that gets wet where the roots are. So in an orchard like this, you just apply it in line with the trees, a little bit away from the tree and very close to the drip lines. There are different recommendations for different types of irrigation systems. Again, you can find that stuff both from UCA&R and also ITRC down at Cal Poly. They both have publications with guidelines about how to install these things. So I've got a hole in the ground. Take this out. So the first thing you need to do is take this little bit of plastic off the end of the ceramic tip. If you leave it on, it won't work. But this plastic protects the tip. You don't want to get the tip dirty before you install it. Any kind of oil will mess up the readings and you won't get valid readings. If it's cracked, you can't use it. Now this thing actually has threads on it and you can remove this porous tip and replace it. You can buy replacement parts. You can also replace the gauge. These, you know, if you kick it or if you have some tractor blight where it runs over it, you can replace these two. And I think the cap can be replaced as well.
Everything on there.
Yeah, so pretty much everything, and you can even buy spare tubes, right?
Yes.
Yeah, okay, so any part of this can be replaced. All right, so the first thing you need to do is fill it up with water. Now Sean has some water. You'll also notice that the water is green. When you buy one of these, you get some dye. It's basically food coloring, and that just makes it easier to see the water. Hang on to that. So you fill this up with water.
This is after you soaked it for 2 hours?
Yeah, after you soak it. And that little hole makes it difficult to get the water in. Yeah, so one way you can do it is just tap it like that. That helps the water get in. But you want the water to go up past where the gauge attaches to the tube.
Do you leave the plastic on while you're soaking it overnight?
No, you take the plastic off.
It's got to be exposed.
And notice there are little bubbles coming up from the bottom. There's still water going in there and air coming out. And it could take a few minutes. And we're almost there.
Yeah, keep going. At least another 20 minutes.
We brought lunch. Don't worry, you'll be out here all day. We got plenty of food.
Let me see it. We're getting real close.
Yeah.
See, it's not super delicate, but you know, you don't want to beat on it with a hammer. But that's it. As long as it's going through the threads and all the way into the tip, we're good.
So once you get in,
Green, basically.
yeah, basically if it's all, yeah, that's the point of the food coloring, is that it makes it all green. I have the cap.
And it's a water-based food dye. If you use a oil-based, you'll clog the tip and gotta get a new tip. So water-based food color. So if you want to be all custom about it, have red instead of green, great. Just make sure it's water-based.
I'm gonna push this down until I feel it reach the bottom. So that's about where it is. So the next step is to get the rest of the air out. And you'll notice that this gauge is reading 0. I know it's hard to see when you're standing from, but the gauge will read 0 when you put it in. And because this soil is really wet, I don't really expect that gauge to go up at all because the soil's wet. But the next step is to get all the rest of the air out. You can get two different ways to do that. One, the least expensive way is this syringe that comes with it. There's another device that's a hand-operated pump. It's a little bit easier to get all the air out. You can apply more pressure, but this is the simplest, least expensive way. And you can replace these. As long as the tip is the right diameter, it fits down into that little hole. And if I can do this without dropping everything, it fits down into that little hole. When I pull on this, you can start to see bubbles come up.
Your pressure went up too.
Yeah, the pressure's all the way up to 90 centibars now. And you can barely see those little bubbles coming out the top. You just keep repeating this process until you don't see any more bubbles coming up. Still a few more.
There's like micro bubbles in there.
Yeah, I think that's bubbles, that air that's still in the porous tip. Yeah, I'm getting up to about 95, yeah. Okay, so we're going to fill it up the rest of the way with water. Okay. Now, there's a little rubber tip. You want that firmly pressed against that hole that's in there. Now, when you're tightening this thing, it's all plastic. So if you tighten it down too hard, it'll crack, and you got to get a new one. So what they recommend is you tighten it down until you just barely feel it stop, and then you do 1/4 turn like that, and that's it. You turn it clockwise, because a threaded tip will come off if you turn it backwards. So tighten it down until you just feel it catch, and then 1/4 turn. That's all you need to do. So that's it. It's installed. It took a couple minutes. You still need to wait for this thing to equilibrate with the soil. And so you can look down there and you can see it's still reading 0. Now over here, we put this one in yesterday. And it's just reading maybe 2 centibars. But if you compare this one to that one, you'll see that this one's just slightly higher. So that way we know it was correctly installed and you've got a hydraulic connection. Did I miss anything?
No.
Okay.
About that one.
Yeah, we'll get to that one in a second. So during the season, there's some maintenance you have to do. If you come over here and you can't see the water in the tube, you need to fill it back up. You need to get the syringe and get all the air out again, and then put the cap down all the way to the 1/4 turn. You need to do that anywhere from a week to 2 weeks, so you just check on it every time you come by. And you're going to be getting the readings off it every day, hopefully, so you'll be out here often enough to notice when it's dry. If you can't get suction to remain, that means that the porous tip has lost its connection to the soil. So when you're pulling on that thing and it's just bubbles coming out the whole time, that means it's sucking air in from the porous tip. It could also be cracked. So if you can't get a vacuum to form, that means something's wrong and you've got to replace it. Every year when you're done, you can pull them out of the ground, you keep the tips wet, and you reinstall it the same way. When you reinstall it, check the porous tip, make sure it's not cracked or too much dirt or soil, not a problem, but oil on from your hands getting transferred to the tip. All of those things will mess up the tip. That means you've got to replace it. But these things have a lifetime of, what, 5 years, 10 years?
Yeah, they can last quite a long time. What I would do is definitely in the winter, take them out. Because there's liquid inside the gauge, and liquid, as you know, when it freezes, it expands. Bust the gauge, there you go. Save yourself some money in the wintertime and take these out. We do have other sensors, electronic sensors, that don't require that kind of maintenance, but for these, make sure you take them out in the winter.
Okay, any questions? Y'all got everything, right? Yes?
So placement, would I want to place that in an area that I think is dry or that's average watering, or how would I?
So if you're going to use this, you want it to be, that sounds nice, but no. You want the gauge readings to be representative of the soil that you want to manage, right? So if you've got, say, 2 soil types and you're managing to the more limiting soil type, you want to have the probes in that soil type. If you've got all one soil type, then it's not too big of a deal, but you don't want these probes close to where the water comes into the system or close to the end of the system, because that's when your pressures are going to be the biggest difference between the average. So you want it sort of in the middle and then maybe 3/4 and 1/4 of the way from the middle.
Okay, and not right by an emitter or not by an emitter?
Close to it. You want the porous tip to be in the part of the soil that gets wet and has roots in it, right? Because you want to measure what the plant's experiencing So you want to measure both the soil where the roots are getting their water from and the soil where the plant is getting its water from, right? So you want to measure what the plant's seeing.
Do you have a recommended number of those per acres?
You want to get an average. The more variability you have in your soil, the more probes you're going to need. 3, good enough, right?
Per acre?
No, for the field, for the management unit. So like if you're managing your blocks separately, you'd want to have 3 for each block. If you have 1 block, you'd have 3 for that whole field. Right? Also, you can buy these in different lengths. So I think they go down to 2 feet.
They go down to 4 or 5.
4
whatever
feet.
Whatever you want.
So you can install 3 of them right next to each other and see how the moisture level is going down by depth. If you install them correctly, you can actually see when the water's going down to the depth that you want to irrigate to. So if you're managing to say 24 inches, you could put one of these probes at a little bit deeper than 24 inches. And that way you know when you see that probe go a little bit more to the wet, you know you push the water far enough. You could install another one at 36 inches. And if you start to see that one go down, then you know you put too much water on, right? So 3 or even 4 of these probes, you can tell not only what's the moisture status in the soil, you can see how far you push the water down when you irrigate. Just like you would with a capacitance probe that's got multiple sensors in it.
Does fertilizer have any effect?
Nope, no effect. It will affect other types of soil moisture sensors.
But this is actually a physical reading, so it's the truest form of soil moisture you can get.
Because the water can flow freely through that porous tip. So you really are measuring the force that the soil applies to the water to keep it from going away. Anything else? We got plenty of time. All right, one last thing. Sean figured this out, or got this to work last night. We took some very dry soil and we installed a tensiometer in that soil. If y'all can get close, you'll see that the tensiometer is reading just shy of 30 centibars, indicating that this soil is dry. Right?
That's my next question. What is the magic number for wet versus dry?
So every crop and every soil is going to be a little bit different. So
This
if
is dry soil, no crop?
yeah, all right. So this is just for demonstration purposes. You wouldn't want to irrigate this because that, you know, why? But if you go on Google and you start Googling crop management tensiometer, a bunch of references are going to pop up. UCNR is always going to be at the top of the list. They have publications with like tables by crop. In fact, I brought one just to give you an example. There's tables by crop. There's also tables by soil, right? In fact, one of the UCNR publications actually has a way to estimate volumetric water content based on tension, but it's a rough estimate and it's by soil type. I've seen studies where like a guy named Suat in Idaho or Iowa did a whole bunch of studies where he measured soil moisture very accurately and tension very accurately and developed a statistical relationship. But one of the problems with that is about the physics of how soil and water work together. There's something called a hysteresis effect, where the relationship between the moisture content and the tension depends on how the soil went up and went down, right? So as it's going up, it's going to be a little bit lower, or sorry, as it's going down, it's going to be a little bit lower, and then as it goes up, it'll go up higher and faster than it did when it went down, right? So that basically it creates this band of uncertainty, and you can't be more accurate than that when you're trying to relate this to soil moisture. But in practice, that band is so small it won't really matter. All right, if you look closely, you'll see bubbles in there. In fact, you can see some air right there. But all these bubbles and air indicate that we need to do some maintenance, right? So where's the syringe?
Syringe. It's operation. Nurse, syringe.
So first thing we're going to do is take this off. Be careful not to mess it up. Now, this thing still feels like it's holding a vacuum because I can feel the plug creating some resistance when I try to pull it out. It comes out pretty easy. You can just hold that.
And when he takes the cap off, it goes down to 0 tensiometer
Yeah.
because there's no suction, right? There's no vacuum.
And I know you guys can't see it from back there, but this is reading all the way down to 0 because there's no suction. So I'm going to put this back in the tube. I'm going to pull this as hard as I can. Can you see those bubbles coming out?
And that comes with it, right, in our little green packet?
Yeah, you can either order this or you can order the hand pump.
Yeah, Marjorie, it's in the packet.
It's in the packet.
The syringes.
This one
And the dye.
and the water. directions, yeah.
Yeah, the directions we have them here in one of the handouts,
Oh.
how to install them. And also to answer your question, there are some numbers here that what they mean.
Yeah.
Yeah, we have it here in the directions, yeah.
Yeah, that's pretty much everything. Okay, so now I'm going to put the cap back on. Thank you.
I'm gonna fill it back up with.
Oh, yes, you're right. I should do that. You were paying attention.
I
I
was paying
wasn't.
attention.
That's why I teach instead of do. Please don't, Jacob.
I won't. Not today.
Okay, and that'll overflow a little bit, but that's not a big deal. So same procedure. I'm just going to turn this until I feel it barely get tight. Right, so there it is, and then it's 1/4 turn to the right, clockwise. That's it. Now, if we come back here, if we've done this correctly, right now it's still reading 0, but in a little while you'll see that needle start to go up. If it doesn't, that means I screwed something up, and we're not getting a good hydraulic connection. Because this soil is very, very dry. This was sitting in one of our labs for like a year, so it's air dried. It's very, very dry. It's not going up yet.
It sometimes takes a few minutes.
Yeah. Well, after lunch, come by, take a look. If you see the needle hasn't moved, say, hey, Charles, you screwed it up. All right, so that's the basic process of installing a tensiometer. Again, look up the numbers that you should use for management on the internet. Again, UCANR is your place to go for that. And if you came here for a free tensiometer and you registered, we have some free tensiometers for you.
Yeah, if you got one at the workshop, you got your one.
Don't be
But if you
greedy.
didn't, we do, and so we can hand those out to folks just over at the table here.
All right. Yes, sir.
You say, so like after you reloaded, you did the maintenance on it like you just did, how long until you would
See a difference?
see a difference or a true?
So what I was told from the manual is overnight, so 12 to 24 hours. If you don't see a change after 24 hours, either the soil's extremely wet or something went wrong. Right? I mean, this one was at 0 when we installed it, and it's just barely above 0 right now because the soil is very, very wet.
That was installed.
Yesterday, or just after lunch, I think.
About this time.
Yeah, so about 24 hours ago. Any other questions? Well, thank you all very much.